Good day, everyone. My name is Chamoji. As you all know, I've not been in my base for the past 1 week, and but you know, your addiction remains your addiction. Okay, so I'm going to be reviewing year one physics textbook for second semester, electricity and magnetism. If you like this video, guys, do me a favor, go to YouTube, subscribe to all our YouTube channels, and also give this video a repost, a follow, a recommendation. Also, we have an online academy where we teach all subjects from grade 1 to university level. Do not forget to come and register your kids. We also do mentorship and order. Let us take them through a very good academic journey. So I noticed that page 6 has the formula for force with respect to charge and distance, and that formula, there's a little omission there. I think it's a typo error, so guys, correct it. So you know, force is equal to K, then Q space equal to over R squared. Now, force is directly proportional to constant of proportionality, which is K. But in the textbook, page 6, Fk was what he got, then raised equal to charge raised equal to R squared. This formula is a mistake, and you guys have to look at it, okay? The professors in charge, please look at this formula again, and you may want to review that formula. All right, so today I want to talk about the inverse square law. So this is the book I'm going to be reviewing. Students in year 1 second semester, if you've not written your exams already, you may want to follow me on YouTube. So I started with the hard part of it because the theoretical part of it has already been there. Students in year 1 take notes. So today I'm going to be talking about the inverse square law. First of all, I want to tell you that Newton's law of gravitational force has its own inverse square law, and then Coulomb's law of electricity and charges has its own inverse square law. And the major difference between them is that they both have attraction, but one of them has repulsive force, and that is for the Coulomb's law. They told you that in electricity and charges, Coulomb's law, opposite forces what? Opposite forces attracts with equal magnitudes along the lines of actions that they act together. But in Newton's law, we are only dealing with attractions. In Newton's law, we are dealing with attractions of particles, right? That's why Newton's law is directly proportional to the square of masses. But in electrical force, it is directly proportional to the square or the product of their charges of one particle and the other. I'm going to elaborate why. You can see some unit vectors, vector along the positions, and then the square displacement, the resultant vector, etc. I'm going to be elaborating on the inverse square law. We're going to direct it into the Coulomb's law. And I told you that in Coulomb's law, we are talking about the force of attraction between two charged particles. Let's say this is particle 1. You know, this is particle 1. Charge 2, this is particle 1, this is particle 2. Then we talk about the force of attraction or repulsion between them. We know one of the laws of electricity and charges is that like pairs will always repel. Unlike pairs, we attract. So when you have the two charges, I'm going to tell you more about the position vector, the unit vector as we go. First of all, we know that force is directly proportional to Q1, Q2, and inversely proportional to the distance, the square of the distance between them. This is what Coulomb's first law. Coulomb in the year 1784 thought of it and decided to study about charges. He studied about particles that are charged. And then he studied about how the attractions happens along their lines of attraction. And he came up with charges repairing and attraction. But this formula is not complete because there's something that is being initiated there, and that is the constant of proportionality. So F becomes K, Q1, Q2 over R2. But something is different, and I want to show you. Where K is the constant of proportionality, which has a constant too. K is equal to 1 over 4 pi epsilon naught. This is it. So it's approximately 9.0 times 10 raised to the power 9 Newton meter raised to the power 2 over Coulomb. This is gotten from making K subject to the formula, and then we're getting this. So let me briefly prove to you how we got this, so you don't keep asking yourself, how did they get 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Yeah, permittivity. Let me be here. I think I should be here, right? Permittivity of free space.